Let's start. Today we are going to cover Spring Web. Objective of today's class will be understanding MVC model, jars used in Spring while developing Spring application, web-based, form handling in Spring MVC, Apache Tiles framework for integration with Spring as a presentation layer, Spring internationalization feature, Spring multi-file upload features. So these are bullet points we are going to cover. MVC is a type of design or architecture, I would say, on which there are multiple framework built on. So let's see what is the difference, what is the extra Spring MVC. MVC stands for Model View Controller, on which there are many frameworks built on, where model can be termed as your beans, Pojo classes, forms, which hold some data, and that data is coming directly from database or from your DAO layer. So that is a model. Controller. Controller is a Java class which handle your all incoming request on the basis of URL, pick or process the appropriate model and send back that model in the form of response to the view. That is the job of controller. Controller is, you can loosely say, it's a servlet. If you guys are aware of MVC1 or older architectures, then in those days we used to code directly on JSP pages, whether it is a business logic, whether it is a DAO, whether it is a connection, everything. So it was MVC1. Nowadays what we are following is the flavor of MVC2. Controller. Controller serves the purpose of intercepting incoming request, process it on the basis of user data, and send back the response. Now come the last layer, that is view. We use mainly a JSP pages, XHTML, HTML, or any other format, depending on your what kind of a technology or what kind of a language you are going to use. So that view combine your objects and the HTML together and send back the response back to the browser so that it can be viewed at your client level. So that is more or less the flow of MVC, irrespective of the framework you are going to use. Whether you are using Spring, whether you are using Struts, whether you are using JSF or FreeMarker or any other framework, if it is built on top of MVC, the flow will be more or less like that only. Model view controller architecture is used for interactive web applications. This model minimizes the coupling between business logic and data presentation to web user, which was not available in the case of MVC1, which has all the code on JSP written. At some places, some of the beans there, but it's tightly coupled code if we follow MVC1. Whereas in the MVC2, it's a little bit different. We have a separation of business concerns in the form of layers, model, view, and controller. Model domain contains the business logics and the functions that manipulate the business data. It provides updated information to view domain and also gives response to a query, and the controller can access the functionality which is encapsulated in the model. View is responsible for presentation aspect of application according to the model data and also responsible to forward query response to the controller. Controller accepts and intercepts user requests and controls the business objects to fulfill these requests. An application has one controller for related functionality. It's not necessary, but it's advisable to have a one controller dedicated to one functionality so that you can have a URL map to it in a Spring MVC. And controller can also be depends on the type of clients, what kind of clients you are going to use. So this is how flows goes from front end to back end. The request is coming, hitting to the server. Server is nothing but your processor, which is black box, I would say, which is deploying your server. That is Tomcat server or JBoss server or any other web or application server which is hosting your application. And that server anticipate the request and route it to the application controllers through some configuration files, starting with WebXML. Then controllers intercept the specific request for a specific functionality, interact with the DAO layer with the help of model, convert that model and convert it into the view and send the response back to the server. This is how your flow goes from start to end in MVC. And using this MVC controller model views, we separate our different business concerns so that we can handle it at different layer rather than mingling it with together. So that is more or less how your MVC works. And we'll see what is the difference or what additional Spring MVC is providing to us. Now, let's see the structure of Spring MVC, how Spring MVC works. So if you see the first two steps, you will see it's almost similar to what we have seen so far in normal MVC architecture, right? So request is coming from the client, it is hitting your server, server is further invoking the request through application. But after that, it is little bit changed. Now, there is a diagram in front of your screen. In terms of request or response for any Spring MVC application, single point of contact is dispatcher servlet. So always remember, thumb rule, the starting point for any Spring web application is dispatcher servlet. The rest, everything comes after that. So if you see here, request is coming to your dispatcher servlet. Dispatcher servlet mapping the incoming requests to the controller and then dispatches the request to the specific controller. Now the question is how it is mapping it. So let's park it for a while. So let's say dispatcher servlet sending the request, anticipating or filtering each and every request coming. On the basis of request, it is identifying the request, it is invoking the controller on the basis of request. Let's say one controller invoked on the basis of request. Now what is the job of controller? Job of controller is the extension of servlet, I would say. So it's more of a, handling your request and response. That is the job of Spring MVC controllers. So it anticipate the specific request with the method. That method anticipate the request, read the data from the request, process the data, call some functions or methods, maybe from service, maybe from DAO, or maybe some utility. It depends on your business, how you are doing it. Now, let's say you have a controller invoked, controller process the data, controller talk to your service layer, brings the data, process it, and now the job of controller is to map the data and send back to the layer so that it can be displayed. Now the job of controller here is it's model the data, which means it's bind the data with the model so that it can travel back with the response to your web page. And apart from that, the difference between other Spring MVC controller and other frameworks controller, let's say Struts or JSF, is to resolve the view name. When I say resolve the view name means which JSP page is going to be invoked. That is the job of controller as well. So it identify, process the data, process the request, model the data, identify the view name, and send it back to the dispatcher servlet. So the loop is complete from dispatcher servlet controller, then back to dispatcher servlet. Now dispatcher servlet have the model data and the view name. Dispatcher servlet now identifies with the help of view name, it actually invoke the view. View means JSP page. And when it's invoke the view, it's converted into the HTML response and sent back to the client. That is your browser. So that is in out of workflow. How request and response flows in Spring MVC application. I'm going to explain it one more example. Then we'll see the code and everything after some time. But I will explain that one example, how its mapping is going on and everything. So if you see the market cover of Spring, cover of market, the percentage is a big, huge. So this is what I have explained, which is mentioned in the words here. Spring MVC, the first stop in a travel of a request is Spring's dispatcher servlet, which is central point of contact. Dispatcher servlet job is to send the request to a Spring MVC controller. Dispatcher servlet consults one or more handler mappings to figure out which controller to send the request. The logic performed by a controller often results in some information that needs to be carried back to the user and displayed in the browser. When controller packages up the model and identify the name of the view, that is what I was saying. It's only identify the name of the view and send it back to the dispatcher servlet. Now with the help of dispatcher servlet invoke the view resolver. And view resolver job is to identify which JSP is going to be invoked. So the view will use the model header to render output that will be carried back to the client by the response object. This is how your start to end your Spring request flows. So to setting up any Spring MVC application, there are certain set of jars which we need, that is a basic requirement for developing any Spring application. So the very first jar we need is Spring core, beans and context, which we have seen multiple times. And you can see in front of your screen the dependencies. Spring core has dependency on logging, and then back and forth, beans on core and context on beans, like that. Then we have a specific web and web MVC jars. Spring web have all the utility and context classes like web application, context, multi-part resolvers, and all those web utilities and third-party framework support, which depends on Spring context and Java X Servlet. Then we have Spring web MVC frameworks, which has frameworks, servlets, web MVC frameworks, web controllers, web views, and classes specifically needed for MVC framework. Dispatcher servlet. Before going to the dispatcher servlet, you guys must be wondering what is the use of and how your dispatcher servlet maps your URL or the request, I would say, with your controller. So for an example, if you see in front of your screen, these are some URLs, let's say. So this is your URL. So your application login, then your application login edit, then application login update. So this way you can say that, let's say this URL is coming. In that case, you need to write a controller, let's say login controller, and you can map your request with your method like this. So login request will come to this method, or login edit will come to this method. So there is two options, one method level request mapping and one controller level request mapping, which can be used as per your requirement. So if this kind of a request is coming, then this controller is not sufficient because it has business in it and we need to write a new controller for it. Let's say business controller. And then we have to map that request or map that URL with that controller. So using the URL, or I would say the relative URL, your dispatcher servlet class maps your incoming request with your controller. So that is annotation based. So dispatcher servlet is the front controller of the system, Spring MVC system, handling all incoming requests and coordinating the different subsystems of Spring MVC. Dispatcher servlet shuttles the model and view written by controllers to appropriate view resolvers. By the way, model and view is a class in Spring. I'll show you what is the use of that class. So the dispatcher servlet also creates the web application context, which contains the web specific components such as the controllers and view resolvers. The web application context is then nested inside the root application context so that the web components can easily find their dependencies. Now, before moving to the next point, so far we have seen application context, right? In the example, we mainly use application context. Now we are talking about web application context. It's specific to your J2EE. Application context can be any normal application, maybe a desktop application, maybe simple jar file, maybe a job, maybe a batch, not specifically a web-based application. So application context in the hierarchy sitting on top, then comes the web application context. Web application context is specifically for web-based application. With the help of application context, we access any kind of a beans in the pool, Spring pool or Spring container, right? Same goes with web application context. It's create a pool kind of a things, and you can access the objects in your web application context through web application context, whether it is a controller, view, resolver, or any other. So it's kind of a branch from the same tree. So for an example, you have created one service, let's say Java service layer, that is a jar file. And you have jar file, let's say this. So far we have created multiple application, right? Demo 5. If you open this form is nothing but a Java archive. It's a jar file only. When you run this application, it's create a jar file for you. So if you open this, you will see in the target folder, so that is Java archive. Now, you want this Java archive to be used in your web application. How you will do that? With the help of application context, right? So that if any class wants to read from your web application context, so now if you see, there is two Spring pool, one under web application context and another under application context. And in these two pools, we can have multiple Spring beans, maybe services bean or DAO beans under application context, and controllers and everything is under web application context. Now the question is how to get the beans from application context pool while sitting in web application context, right? So that is what we are going to do with the help of web XML and context config listeners. We have a listeners here using which we can load the application context in web application context. We can inject that. Now the last point is to locate the XML for the web application context. The dispatcher servlet will by default take the name of its servlet definition from web XML. So if you guys remember, for application context, we have one XML created, right? Spring Bean configuration, application context.xml, core.xml, whatever name you want to give, you can give, right? Similarly, for web application context, we can also create one XML that holds all the beans for your web application context or web application, which is known as some servlet XML. So there is a method or there is a way to define the name of that XML file, and that definition should be in your web XML. So you take the name of the servlet, then append -servlet.xml, name of the servlet -servlet.xml. That should be the file name, and that file should be under webinif folder. For an example, if the servlet name is Spring, the name of the servlet here is dispatcher servlet, right? If it is Spring, then your servlet name should be spring-servlet.xml. Here is the web XML example. Here is the servlet and servlet mapping. What should be the name of XML? As I said, it's servlet name plus -servlet.xml. And the servlet name here is first test, which means first test -servlet.xml. That should be the bean name. Let's start the creation of application. So let's see the web XML first, then we'll move and see the form submission and everything, examples and all. How to create a web application? Starting from scratch, new project, say Spring Legacy project. Next, name it Spring MVC demo 19th November. Select Spring MVC project, say next, choose the package name with the name, company name, and my app, my Spring app, and say finish. So if you see here, an MVC demo is created here. With MVC demo, it will create everything for you with the dependencies, with the libraries, structure, everything. So if you see here, the structure is created, web main, web app, webinif, and everything. So before going to there, let's see the POM file first and see the dependencies. Let's change some dependencies, context and web MVC. Rest should be fine. Remove it. Now add some dependencies, r.spring framework, starting with core, then beans, then context, web, then web MVC. Maybe I should have web MVC like this only. So now I have all the dependencies. So let's check out some other things. What should be the first thing after pom.xml we should see in a Spring web application or any web application, I would say? The first thing for any application, we should go after dependencies as long as you have your jar is web.xml. That should tell you the starting point of your application. So if you see here, I'll go to this part afterwards. Let's see the rest of it. You see here dispatches servlet already there. I don't need to create it because when you create application from scratch with the help of STS or Eclipse, it gives you these facilities. So this dispatches servlet is part of Spring Web MVC jar. There is two ways to name your context servlet file. If you see here, what should be the name of my servlet XML file? If you want to go by default, if you don't want to name your servlet XML file in your XML, you want to go with the default, then you pick servlet name, then XML hyphen servlet, then XML, and then place that in your webinif folder. But if you want to configure it, it's not hard and fast. If you want to configure it, if you want to place it some specific location, if you want to name it something specific, so in that case you can use init param. Init param, then the param name is context configuration, and then you can provide the servlet XML file name whatever you want with the path. This way you can override that default thing. So this servlet.xml holds your web application related things. First thing first, resource view resolver, which will resolve your JSP, and then the component scan for you. So that's what I want to show you. Let's move further and see what is rest here. Then we'll start developing or adding classes here. Then we'll start adding configurations here and developing the application step by step. Now, controllers play a crucial role in web application. They execute the actual request, prepare the model, and select a view to render. The controller is the glue between the core application and the web interface to the application. It's responsible for responding to the actions taken by the user, whether it is a form submission or a click or simply accessing a page through URL. So in all these cases, controllers and its method will be invoked depending on the request you executed. Now, I have placed context component scan here. What is the reason? Why it is here? Why we need this in servlet context? We place this context component scan here with the base package. Why we need this? That is specific to what we did earlier, right? How dispatcher servlet is going to load all those mappings and the controller. So nothing is magic here. So we use context component scan to load the annotations, right, used in your codes. So which annotation this servlet context is talking about specifically? Annotation controller. If we're talking about servlet context XML, it's all about web application. Remember that. It's not about application context. Web application context, it's about controller, right? Like this. You put annotation controller on top of your controller classes only. And using that annotation, dispatcher servlets identify that this is the class which we need to load. If you don't put annotation controller on any controller class, it will not take part in that request and response loop. It will be treated as normal class. So that's why we need context component scan so that we can load controllers. Now, we have another annotation which is used to map your request. Annotation request mapping. This annotation serves two purposes. It identifies ABC method, any method you put this annotation on top of, as a request handling method. It will not be a normal method. It will only for a request handling method. It also specifies that this method should handle request which path start with /. You can specify comma separated values in case to represents multiple path. When a model and view is returned, this is used as is. It should contain the full model to use and the name of a view to render. We can also return string value, that is the logical name of the view that should render the results. Let's talk about the use of internal resource view resolver. If you see here in the XML part, we have used this bean, which has internal resource view resolver, which is a part of Spring MVC, which takes two properties, getter setters, prefix and suffix. Prefix is the relative path of all your JSP pages or JSP files, and suffix will be the extension of the file, like .jsp, .html, .xhtml, .page, or any other dots or extensions. Now, the class name is internal resource view resolver. The job of this class is to find a view template contained within the application's war file. The path to the view template is derived by prefixing and suffixing the logical view name with the help of prefix and suffix property, which merge and form a complete logical view name for any JSP file. So if you see here, home is the string which is sent by controller. Controller is sending the string, the name of the view, let's say home, and that home is taking the prefix and the suffix and merging it together to form a logical view name, and that is done by your internal resource view resolver. Your controller method return back some string, the name of the view, and with the help of internal resource view resolver, takes prefix and it takes suffix from your XML configuration, and it's merged and give you the fully qualified logical view name. Let's say controller is returning login. How it is going to be identified? There is a prefix here and suffix here, webinf JSP. If you see here, we have this. Now to access the business.jsp, what should be written by controller? You can see the prefix and suffix here. I need to access business.jsp. What should be the written value from controller? What should be the string? Check the prefix and suffix. What should be the written value from a string? It should be business. It should be like this, because prefix is this and suffix is this, then it will form it. We have multiple folder, JSP folder, then business folder, then account folder. There is an HTML folder, then something like this. I need to access home.jsp. What should be the written value? Now, there is a twist. I have HTMLs as well, some other file. I want these HTML to be loaded. I need to add another bean. I can have multiple resolver. We can have one or more than one internal view resolver. That is the flexibility and agility Spring provides. That is one of those, and there are so many. You can have any number of view resolver here. You can load JSP, you can load HTML, you can have a altogether different framework for your view, and you can use. So for an example, if you need to change the presentation layer, you don't need to touch the code base. You just need to touch the configurations here. That is loosely coupled. You can have multiple JSP. So let's see that. One example. You have seen WebXML here. You have seen Servlet context XML here. Rest we'll see one by one. Let's see the controller which is created automatically for us here. Here is home controller. This is controller annotation. And then there is a request mapping. And then there is a model. Model is an interface here, which is a part of Spring context. So what it does, if you use this in your method, when you add anything onto the model, let's say model.add attributes server time. So if you are aware of that request method, request.set parameter, request.get parameter, if you worked on HTTP servlet, HTTP request, so it works on the same way, same pattern, setter and getter, but the method name is different, add attribute, model.add attribute, server time. What should be the use of this? I am adding this, add attribute server time. What I am going to do that after this? It's the equivalent of request.set parameter, almost. It use maps. So we use this model in the view. So view here is home.jsp. So when you open this home.jsp, you will see I am saying the time on the server is $server time. This server time is the same what I have done here. Or if I want to add something else, message, and then go here, done. I have added another attribute here, MSG. Now let's deploy this on the server Tomcat. So let me delete this configuration. You get this option here, server. Click on to create a new server. Whichever server you want, you just use it, JBoss, Apache or whatever. I'm going to use Apache. The version in 7. Then I will go and add from here. You just need to provide the location. Where is your Tomcat on your machine? Just provide this here like this and then say finish. So it will add the Tomcat here internally. Now what I'm going to do, I'm going to run the Tomcat in a debug mode so that it will come here and show you the request part of it. So when I say start, before that I will need to add the application, add and remove application. So Spring MVC demo 19th November, finish, then start in the debug mode. So it's starting the Tomcat. So when you see the console here, you will see it will load, because since we have only one method, it will load only one method. So if you see here, I have only one controller. This method is getting mapped here. This is how all the controllers and methods mapped here like this. So if you see here, it's saying that method is get, string request mapping is / that is home, and the fully qualified name, home controller, home method with the signature. This way it loads each and every controllers and methods at the time of startup. Now let's hit the request. So if I hit that and see that request is hitting, debug point is coming here. It's coming with the model, object, and the locale. So locale is default one, enus, F6, then you'll see it adds the model attribute here. If you see here, server time and message is here. So if you see here, hello world, time on the server is this. This is my first Spring MVC application. Adding models. Models means beans, forms. The form value that a user enters in a page can be configured to be collected in a container or model object and given to the controller for processing. So the form which we use on HTML page, and we ask end user to fill up that form, and we use that form values at server layer or a controller, then further process it. So how to use that? Let's see that. So the objects that hold form values are known as command objects. Command objects are specific to Spring MVC. It's only on Spring MVC, not somewhere else or any other framework. These are simple POJOs created with variables and getter setter. If the variable name matches with the request parameter name, for an example, string name, string ID, string email, so it matches with the HTML parameter, then the request parameter value is set into the variable automatically. So if you guys remember from the old days, what we need to do, we need to use the request parameter to read those values from the request, right? When we submit the HTML form and we have input parameters there, then we need to read that values from the request parameter directly by calling that request.get parameter this and that, and right, and then we need to do that. But Spring has abstracted that. If your parameters and your with the help of command object, it's the same attributes what your form is holding with the getter setter properties, that it will be directly mapped with your beans. You don't need to use the getter and setter for it. Which Spring MVC class works as a front controller in Spring MVC? A, B, C, D, dispatcher. Before using the form tags, let me show you how it is used. What is the difference in compare of normal form and Spring form? So apart from Spring applications support normal HTML form as well, but what Spring provides? Spring provides its own tag libraries. So it also provides Spring form tags. Spring provides a comprehensive set of data binding aware tags. for handling form elements when using JSP and Spring Web MVC. So each tag provides support for set of attributes of its corresponding HTML tag counterpart, making the tag familiar and intuitive to use. Unlike other form input tag libraries, Spring's form tag library is integrated with Spring MVC, which means your tag library is part of your Spring Web MVC jar, giving the tags access to the command object and reference data your controller deals with. So let me show you. So if you see here, I am opening Spring MVC jar. Apart from having Java classes, it has some tag libraries here as well. So if you see here, Spring TLD, Spring Form TLD, Spring Tooling, these are some tag libraries. So if you open these TLDs, you will see the description of tags here. CSS class, CSS style, on click, on mouse out, or form. Maybe you will see form here, form tag, input tag. So since it is coming bundled with your jar file, so it's easy for the developer to work with. It can easily map the incoming data which is coming in the form of form which you are posting, and it is directly reading it in your controller. That's the reason is. Other form or tag libraries, come separately, but Spring Form tag libraries is part of your web MVC itself. So giving the tags access to the command object. When I say command object, it means form beans and reference data your controller deals with directly. You don't need to go for request getter and setter kind of a thing. Now, first thing, how to use this in your application. The form tag libraries comes bundled in Spring MVC jar file. The library descriptor is called Spring Form.tld. To use the tags from this library, add the following directive on top of your JSP page. Let's say taglib prefix form URI should be Spring Framework form tags library. So here form is the tag name and prefix whatever you want to use. So this way you can access all the tags on your page. We have a different tags supported for different things. Like for form, we have form tag. We have support for input tag, checkboxes, radio buttons, then password, select, hidden. So Spring Form support all kind of tags which is available in HTML. Can you tell me the answer of this question? Request mapping annotation is used for mapping incoming web requests to appropriate handlers. So this is how we use form tags. Let's see how it is used, then create some application out of it. So form tag, if you see here, the action here, what should be the action? Method, post, command name, user form, and then you can have input path. This is the path we use to map with the command, and command should be your bean or a form. Let's say path is equal to username, path is equal to password, path is equal to email, like that. Similarly, we need to create a form, a model for that with the getter setters around it. And then we using model attribute, we can map it with the user. So let's see the code first. Let's create a controller here. What should be the first thing I need to do here to identify it's a controller? Annotation, controller. So before going to here, I need a beans. So let's see and create a bean dot bean class business.java. Let's say string business ID, string business name, string business email, string business address. Now I have a bean, form bean here. So I need to open a business page so that I can submit some business detail. So I am going to give a link from home page to my business page. So what I am going to do, I'll say this, and login URL is coming from 24th September controller, home controller. So I need to provide login page here, something like this. I'll say business submit. So I'm using some JSTL tag to form the URL. So what I am going to do, I have created a controller. I am going to create one page where you can, or where user can submit the details and further read that detail and send back that detail to the DAO layer for saving it into the database. Now, before that, I should have a page. So I'll say public model and view business home. So I'll say model and view. I'll say written model and view. I'll tell you what is the use of model view. Now, this will serve the page for request mapping. If you see here, in the request mapping, this many options I have: consumes, headers, methods, name, param, value. So I'll say value is equal to slash get business method is equal to request method dot. This will be a get request. So this will have the view name business. This will have the form business form, and this will have the form object. How we are going to use, I will show you. So what model and view is doing, let me take you to the source code. So I have three parameters in model view constructor. One business, another is business form, and that third one is object. So if you see here what it is, first is the view name, then the model name, the model we are going to use on the page, JSP page, then the object, view name, model name, object. I have created one method, and that method is to return a JSP. I need to create a JSP, right? So under view, I am going to create a business.jsp. So let's say JSP file business.jsp. Next, finish. So I have business.jsp. Now I have business.jsp. Create a form. We need to create a form here. For the creation of a form, what should be the first step? So let's import tag libraries. Prefix form URI. In the URI, if you see here, I am getting everything here because I am having all the jars available in the STS. So that is the plus point with the using STS and all. So I have form here. Now I need to create a form. Let's create a form. If you see, I am getting everything here. Action should be post, business, method, post, command name. I am taking back you to the controller. Let me take you to the source code now. View name, model object. This is business form. This is the command name or a model name, whatever you can say. Now what we need, let's create a table. Or should we need to create a TRTD? So I have TRTD here. Let's copy paste. How many attributes we have in the business.java? 1, 2, 3, and 4. Let's copy paste 4 times, right? Here what we are going to do, form input business ID. So what we are going to use, business ID, business name, business email, business address. Business name. What we need to put here, exactly same what we have in bean. If there is any spelling mistake, then we will get exception. Then we need submit. Now we have a JSP, we have a controller. So when we submit it, it will call post business. Now I should be having some method for post business, which can handle the submit part of it. I need to create another request or another method. So let's do that. Now I need to save the business. If you see the JSP file, when we submit it, this information will be flowing in the form of business form, annotation, request, mapping, value, post, business, what we have mentioned here in the business JSP, this, or maybe let's make it a little bit more meaningful. Save business method dot post. Now I need to add the model attribute, which is traveling. Which model is traveling with this request? To map your incoming parameters, which is coming like this: business ID, business name, business address, business email, then submit. We need to map it here. To map it, Spring provides one annotations, which is known as model attribute. Here you say business. What we need to provide here in the string to map it, exactly the same thing, which is there as a command object. Then to be further develop the application like we used to develop, so I'm just explaining you how we actually doing in the business. I mean, it's not like a normal demo, how to really create the application. So go create another package. Let's say this, then say service. Here you can go ahead and create another class. Let's say this class, then say business service IMPL. Here you can go and say annotation service. Then you'll say public string save business, and you need to create an interface business service. You need to add method here. I'm doing other way around, implements business service, and you can say here business service. Then you can further create another package. Let's say DO. In that package, create one interface. Let's say business DO, and then say method is public void save business. Then create another class business DO repository. Let's say business DO. Now add an implemented method. So make it call either through Spring JDBC template or ORM. Now what we need to do in business service IMPL, I want to inject business DAO. I need to inject business DAO in business service to call the method. Now here is the business controller. I need to call service call business. So I need to add business service here. Again, annotation auto-wire. So call business service dot save. Code is almost done. Here it is, home.jsp. Say use this. I'll say model dot add attribute. So let's go back to the web XML and see what is missing. So in the web XML, if you guys remember, we know everything is here, servlet.context, everything here. How we are going to identify annotation service, annotation repository, and all annotation things. So far, we discuss about web application context. We have not discussed about services, right? DAOs. So for that, we have another XML file created here, root context.xml. So this root context.xml will be loaded by context loader listener class, which is a part of Spring Web. So if we have any dependent jars, if we have any dependent layers, let's say core layer or service layer, where you have another Spring application context XML and you want to load it. So you can load it here. So let's open this root context. So in this root context, I need to open context and I'll say right click component scan base package co.edureka.service and then co.edureka.dao, comma separated service and DAO. So I have this co.edureka.myspringapp.service, right? So let me check the context servlet XML file as well. Even this one is covering for me because it is still my Spring app. So shall we run the application now and see what's happening? Publish, debug. I'll show you this time. You will get multiple entries here. save business, get business, and home. So let's run the application. So let's go from here, F8. I have a new link here, post business details. So when I click on this, so it's not business submit, it's get business, right? So I need to change the URL. It's get business. Let's change the URL in JSP page, home.jsp. So it should be get business, right? Now I am getting get business. So click on this and get business is here. So debug point is here. Now you will see I'm just returning model view. Here you have model map, business form, and returning this back. So I should be getting this. So business ID, business name, address, and email. So let's say ID is 101, business name is let's say Paytm, address is let's say Noida, India. Let's say paytm-help@paytm.com and submit. As soon as I submit, it will take to me here. And if you see business service is further injected properly, business is coming as a model, Noida, Paytm help 101 Paytm. If you want to go inside of it, you go inside of it, service, you say DAO is populated here. So it's sending back, it's saving the business through business service, DAO, and returning back the name, and further taking you to the save business.jsp. So we have added one attribute, save business, for home page. This business added successfully. I'll get the message on home.jsp. So Paytm details successfully saved into database. End to end, how application works, you know now. If you have to create web application with web services, DAO and everything, and how to send back the response to the new JSP or any other JSP you want. Form validation. In the below class, we have used JavaX validation API to validate the bean values. So for an example, if you want to do the server-side validation, you can use JavaX validation framework API to validate the beans values, like if it is exceeding or if it is, the size is less than what is there. Let's say minimum is 4, max is 15, or value should not be null, to match the pattern for email, regular expression. So these kind of a validation you can put with the help of JavaX validation API in your example, and you can use it. You can easily merge JavaX annotation and Spring annotation together like this. There is one JavaX validation annotation which you can use for validating incoming form values. Let me show you one project which is already created. So if you open the POM file, apart from rest of the dependencies what we have, you see there is one validation framework API, that is validation API. If you open the login controller, if you see here, we are using annotation valid on top of the form bean here, which is having min, max, and message along with mail. So using this, you can do the validation. So let me show you while adding and running it. So it will do the automatic validation with the help of annotations and JavaX validation API. Spring_51. So here is the option for username, password. So as soon as you write something, so if you see here, 5 is the minimum and 50 is the max. So if you write something like this, then you will get the validation error here. It will hit this and it will say it has errors. So if you open this, it will say field error in object user, field username, rejected value 1, 2, 3, 4, size should be greater than 5. So it returns and it will say size of the username should be between 5 and 50. That is coming with the help of validation API, which is configurable. You can use the any message you want. When you put the right, say username, password, hit here, it will come back, check it, and send back the response. So apart from doing client-side validation on JSP pages itself with the help of scripting languages, JavaScript, jQuery, or any other language you want to use, you can implement server-side validation as well. Now, what kind of a help Spring is going to provide to implement I18N feature in your application? So to use the internationalization feature in your JSP pages, first you have to define some extra beans which is provided by your Spring APIs. Session local resolver or cookie local resolver, any of these you can use up to your requirement. Locale change interceptor for changing the locale. It works as an interceptor design. And third bean is resource bundle message source, which is used to load the properties file as per your locale. Now, what is the use? It allows you to retrieve locale and time zone from the session that might be associated with the user's request. So if you have to retrieve the locale and time zone of the user logged in, or maybe the user who is accessing your application, you can use session locale resolver. That can also be done with the help of locale resolvers. It's up to you to decide which one to use. Then we need to register a bean in your XML configuration, Spring Bean configuration, locale change interceptors. Using this, you can enable changing of locales by adding the locale change interceptor to one of the handler mappings. It will detect a parameter in the request and change the locale. So when your request is coming, locale change interceptor retrieve the locale, which means language and country, from the request header, and on that basis, on that parameter, you can simply change the entire language for your application with the help of that. Third bean we need to register in XML configuration file is resource bundle message source. It's again Spring context, I guess. It resolves the text messages from properties file based on the selected locales. So for an example, if you are going to support 3 languages in your application, maybe English, French, and Spanish. In that case, what you need to do, you need to have 3 properties file for each locale. And on the basis of user request, the properties file or the text messages will be loaded by fetching the locale from the request as per the user session. So that is the job of resource bundle message source, which is used to load properties file for you. Point to be noted here is that if you do not register any locale resolver, accept header locale resolver will be used, which resolves the locale by checking the accept language header in the HTTP request. Now, how to use that? It's pretty straightforward. You don't need to write much piece of code here if you are going to support I18N feature. Only you need to make sure that you have the content for each locale, and you need to define that content in your properties file. So you need to register first session locale resolver in the form of bean, and there is a property you need to add which can be default locale. So you can define any default locale you want. So here it is English, EN, IN, EN, US, or whatever. Now locale interceptor we need to define as a bean in Spring configuration file, and in the property getter setters we need to define the param name. Value can be any language or lang, whatever. So using this language or lang, this is get intercepted from the request, and it will pick that language from the request and change the locale with the help of locale change interceptor. Third is resource bundle message source. It's a context file or context jar from Spring, which loads all the properties file from your class path, which is available in your application. And it takes the property as a base name, and value can be anything, let's say welcome or messages. So it will be the name of the properties file, which says welcome.properties in this case. So that will be the default one. How to use these properties on JSP pages? We need to define these properties so that we can change the language with the help of these properties. So there is a tag provided by Spring, message tag. So you need to define that tag on top of your JSP file, and using Spring message code and text or code or value, you can change the static text on your JSP pages so that it will load the specific language for you as per your choice. I'll show you how it works with the code. So maybe it's time to see the code. dependencies, if you see, it's more or less same. We are using core context beans, web and web MVC. The change you will find mainly in configurations. So in the web XML, if you see here, we have normal dispatcher servlet. Then we have servlet XML. Here you will find the changes, what we have discussed. Component scan, internal resource view resolver. Now the main change. Message source. So for message source, we have used reloadable resource bundle message source class, which is a part of your Spring context here. So here we need to provide the base name and default encoding. Default encoding for it is UTF-8 because we are going to use some languages which has some special characters like Spanish, French and all. In that case, we need the encoding. So we are using encoding as UTF-8. Apart from base name says value class path messages. So from the class path, it will read the messages. So when I say messages, it is messages properties file. So messages underscore CN is Chinese, messages underscore EN is English, messages underscore FR is properties, which is French. So this way it works. This way it loads all the properties file at the time of startup, and it will place those properties file in the memory. And whenever there is a change in the locale, it will pick the data from that particular property file. Then we have a locale change interceptor. In the locale change interceptor, we use locale change interceptor class, which is part of Spring Web MVC and I18N package. Here, the param name is the part of language. So language is the request parameter, where you can say lang is equal to fr, lang is equal to en, lang is equal to cn. And if you don't pass lang in your request, the default locale will be picked from here, that is English. So we are defining the session locale resolver with the help of value default locale and the value in English. So we need to inject one interceptors in the handler like this. So if you open the controller, in the data controller, there is nothing as such, only data you will see here, which is a get request. Here, if you see, we are auto wiring the session locale resolver, and we can change the locale resolver on the basis of request parameter coming in the request. Otherwise, it will pick the default locale. So let's see that it's running. And before that, let me show you the properties file. So these are the some properties file: first name, email, telephone, add contact and all. Label dot first name, value, key and value pairs. If you open the French, you will see the French language here. In the CN, we have these kind of a value, just for the demo purpose. And how to use that in the JSP pages? If you open the data.jsp page here, you will see at the top, I have imported tag libraries here. This time I did for tags. So now how we are using it: Spring message code is equal to label.first name, label.last name, label.email, telephone, add contact and menu. So this way we can change the static text with the key value pair of properties file. So chain locale resolver. So I'm going to hit the data without request parameter. So if you see, debug point is coming here. At the very first, I am not using any request parameter. So if you see, locale resolver is picking the default locale, and default locale is getting picked from your Spring context file, which is loading the language for you. So if you see here, right now the default language is English, which is getting picked. But since we have not set anything in the request parameter, the request parameter will be null and it will not go there and change the default locale. So this time it will skip it and it will show you the English language. But next time, if you use, let's say, FR, and it will come again here, it will check the locale, it will check the parameter, it will pick FR. Now this time it will change the locale resolver and set the default locale as a French. So this time your locale resolver will be changed and your default locale will be FR, and it should show you the value here. So this way you can drive the data for your application through locale resolver. So now Spring provides you the biggest of functionality to the smallest of functionality. So with the help of Spring, you can easily implement the biggest use case for your client or the smallest of use case of client. So if you see, with the help of just 3 configuration here, 3 beans, message source, local change interceptor, and local resolver, you can simply handle, or you can simply support the internationalization I-18N features for your application, even with the special cases or those languages which is not easily supported, like Spanish, which has some special characters, Chinese, Japanese, and all those. So with the help of these, you can easily implement your I-18N feature. You need to provide the data for it, because that is the very basic requirement. You should have the properties file to support that. But if you have those data, just place those data in your properties file and you can easily configure it in your application. There is nothing fancy, or there is nothing, things Spring is providing for this, but with the help of one easy bean configuration, you can support the multi-file upload functionality in your web application. How? I'll show you. Spring Framework provides Commons multi-part resolver class, which is a part of Spring Web. This class needed to handle file upload operation and multi-part file upload that represents the file uploaded by user. Commons multi-part resolver is an implementation of Jakarta Commons file upload, which is extended by Commons multi-part resolver. So if you open the code for this, you will see it's extending this, which is further using Apache Commons library. So behind the scene, it is using Apache Commons library, but it's extended that and it's built something else on top of it. So multi-part file represent an uploaded file received in a multi-part request. The file contents are either stored in a memory or temporary on the disk. So if you see here, multi-part resolver is something else. There is one, yes. This is an interface in your Spring Web Framework, which has get name, file, and all the files related operation. You can see here all the methods: get original file name, get content type, is empty, and all those kind of. So all kind of a file operations you can see in this multi-part file interface. So in either case, the user is responsible for copying file contents to a session level or persistent store as and if desired. So the base thing is here that Springs give you an options to fetch the file in the form of multi-part from your request. And after that, you can use any API you want to read it, store it, whatever you want to do. You can use any other API to process it. Whereas Spring itself provides some utility classes as well, which you want to use, you can use it. For an example, there is, I guess, file util something. File copy utils, file system utils. So these are some utility class provided for handling file in your application, which is again the part of your Spring API. So the whole story is that Spring provides you one bean, that is Commons multi-part resolver, which you can use in your Spring configuration files. And using that, you can easily load any kind of a file from your request and read it and save it wherever you want. To process that file, you can use either Java file APIs or some other APIs. That is up to your requirement. File upload form. Before uploading a file, we need one file upload form, which can be your Spring form, where your encryption type should be multi-part or form data rather than something else, because in this form, this is a special kind of a form which is going to deal with files only, not form data. So we need to make sure that encryption type is multi-part or form data for your HTML form. So here we need to know that Spring itself doesn't provide any file upload tag like submit button. So you need to provide the submit button with the help of input and the file upload with the help of input, where you can say type is equal to file. So here we are using the input tag to take file. So encrypt type should be multi-part form data, which is mandatory in the HTML form, so that it can differentiate that it is not a normal form where we provide data. It's a form for uploading file in the form of multi-part. So let's see the lab for it. There's a file upload. This file upload you can find in your LMS. It is a part of LMS as well. So in the file upload, let's see the dependencies. Apart from Web MVC, we have validation API as well, and Commons file upload API. Commons file upload is a Apache Commons library which is needed by multi-part resolver, which is the class of Spring Web. So we need to add these dependencies as well. Now, going back to the code, if you open the web XML, there is nothing new in the web XML, only dispatcher servlet. And with the help of servlet name, we are creating the servlet XML here. In the servlet XML, we just need to add one bean for uploading file, this multi-part resolver, commons multi-part resolver for supporting the multi-part file. So if you open the controller here, the first thing to upload a file, we need upload form. So if you guys remember, I just mentioned at the start of class, I guess Asmit was asking the question. So whenever there is a form, use model in view. And if you see in this is a get request, but this time we are using annotation model attribute here rather than here. So this will take uploaded file as a form. This is a file form where you have a getter setter for multi-part file. So if you are dealing with a file upload form, we need to create a form as well here. Let's say uploaded file form. And in that you need to have one attributes that is a file, which is multi-part file. Then you need to have a getter setter for it because we will use this in your JSP page. So let's open this JSP page, upload form.jsp. In this JSP, we are using the form tag from Spring, and the form which we are using here is Spring form, but the encryption type is multi-part form data, not a text. So what I am defining here, model attribute is uploaded file, and the input type is file. This file is coming from this property. So it should be matched. Otherwise, it will give you an error. So this is uploaded file attribute, which is we have defined in your controller. And then the action is file upload. So when you submit this, it will call the action file upload. And this action will take you to the upload controller and the appropriate action here. Here file upload is your request mapping value and the method is post. And the request param, again, you can see is a file. So if you see here, we are using request param. So you can also use request parameter for your form attributes as well. But if you want, you can use model attribute as well, depending on your requirement. So here I am using multi-part file. Using this file, I am reading the file name and the input stream and then further saving it in the D drive. That's what I am doing with this controller. So let's open the D directory. Now, if you open it, it's the file upload form. It's giving you the form. This is your file upload form, which is loading the JSP file, upload form.jsp, Spring file upload. Example, please select a file to upload. So you can click on browse. You can pick any file from here you want. Let's say Spring form TLD. So when I select it, it will show you the name here and it will load it and save it here in the D drive. So when you upload this, file upload successfully for this, and the file name is springform.tld. So if you see here, there is a file in D drive. So the point is that though it is a very small functionality, but just to share the point is that Spring even support the smallest of thing to make the life of developer bit easy in compared to what we used to do earlier. So most of the thing are configurable. You can use the XML file to change that configurations. So less piece of code for implementing these functionality. Now, if you have seen it, I mean, there is a very small thing which we have used multiple time here in the XML files. If you see, I have mentioned this line multiple times. So what is the use of this? Let me show you. Again, it's a very small piece of thing, but it helps us to build an application. Requesting static contents. These are also part of your web application. It's a very common practice to put all your CSS files in one directory, JavaScript files in some other, and images in some other directory. So when we create the file structure for web application, we create something like this: webinf, JSPs, CSS, then we have some JS, then we have some images. So all the CSS file lies here. Maybe if you have 50s and hundreds of CSS files, then maybe you can name it with the module, let's say business then you can say business.css, then you can say edit business.css, and so on. Similarly, you can have action.js and so on. Then you can have business images, account images, profile images, like this, right? So you can have this structure ready here with your application. And on that basis, in JSP file, we need to write something like this: image source is equal to /images /business icon.png, like this, right? This way we used to write. We used to do this just to minimize the size of your container. If you have to deploy your application, the size should be smaller. So if you put all the images in your WAR file, the WAR file will become huge. So rather than having the images in your WAR file or static files like JS, CSS in your WAR file or part of your web application, we can have it somewhere else on server. Maybe some CDN servers, content delivery network, or somewhere else, or maybe some machine. So in that case, what we need to do? We need to take that files somewhere here. Let's say user, my app, static contents. So now this is your base directory. So there is a plan to change the location of static files for your application, and you decided to change the size of your WAR, and you decided to pull all the static files from your application and make it or save it somewhere else, so that we can reduce the size of WAR file. My question is that we have images, we have JS, we have CSS, and we are using that in our JSP pages. Now, out of a sudden, we decided to change the path, or we want to move the static content from the WAR file to somewhere else, some server location, some content delivery network, or somewhere else. The thing is that path is going to change like this. So it will become prefix and rest is the postfix. So what could be the challenge? If the static content is sitting on the server itself, not somewhere else, then how it is going to happen? So how we are going? The main challenge is that we have maybe hundreds and 200s of JSPs, and we have mentioned source, or for JS something like this, for CSS something like this. So there is a big change in your JSP file, right? You need to change each and every JSP file, and there are multiple lines to change it. With the Spring, it seems easier. So now Springs provide us this MVC resource mapping, where you can use the mapping and location. So in that case, you can change the structure or location whenever you want. So it's like MVC colon, I guess, resources, you say mapping, then say location. So location can be something like this, which is dynamic. Today it is something like this, or maybe tomorrow something else. Your base location will be something, mapping is like you'll use static contents, and further this will change something like this. In that case, you will use static contents here, something like this, and you can easily change the location whenever you want. So now everything is on place. If you need to change the location, you just open one configuration file, application context file. Maybe at some point of time, you want to use content delivery network. Let's say HTTPS myapp.cdn.images server. So now you want this server to render all your images. So what you can do, you can simply change the location here. So in that case, it will change it here, and your images will be served like this. No need to change the JSP files, only configuration file. So it's a very small feature, but it's very powerful. So let's move on. Now, even the exception handling, it's not necessary that you always use what is provided by Spring, but Spring gives you the options to do the smallest of thing or to the biggest of thing. So for the exception handling on a controller layer, Spring provides some annotations which you can use to handle the exception if it is coming on your controller. Spring MVC provides a great way to handle exceptions and errors on your controllers. There is an annotation provided by Spring, that is annotation exception handler, which provides you the core feature. Each Spring controller, we can simply define a method that automatically gets called if any given exception occurs. So for an example, you have one controller, let's say login controller. If there is any class not found exception, if there is any IO exception or any your customized exception, let's say my app exception. So if you see that any exception is going to occur in any of the method of your controller, let's say login controller, you just need to write this method with annotation exception handler and exception class inside the bracket of it. In that case, this method will be invoked whenever any exception occur in any of the method of your class. So this method will be invoked in case of exception, and it will return the JSP, which JSP you would like. So for an example, if it is my app exception, so you can return my app exception.jsp, so that you can customize your exception and your pages depending on your exception. The functionality which is Spring providing here is that you can customize your error pages on the basis of your exception. If you think that whenever there is an IO exception in your application, you want to show some specific page to the end user, then you can write that page, you can write that JSP, and you can write this exception handler method in the controller, and you can show that page to the end user. So this flexibility or agility provided by this annotations, which is part of Spring MVC. So in this case, if there is any error or exception like class not found exception, rather than showing some random message to the user, you can open the class not found error JSP if you find that is relevant for your business. So this way you can customize your exception and the page which you want to show. But here is a catch. This is specific for your controller. For an example, if you are getting class not found error or exception in, let's say, business controller or maybe account controller, then you need to write this method there as well. So this is a kind of a code redundancy, right? So you're writing the same piece of code almost all the classes. So to avoid that, Spring provides another annotations, that is annotation controller advice. So in that case, what you can do, you can write one specific controller to handle exceptions. So in that controller, you can write annotation controller advice on top of the class and the annotation exception handler for your methods. So whenever there is any error in any of the classes, it will open the respective JSP page for the user. So this way you can make it centralized with the help of one class. So Annie is using Spring Framework provided form tags, but it is not working correctly. What could be the possible problem? Remember, I want to use a form tag. So somehow it's on JSP, it is not working. I'm not able to get it. Most probability is that we have not declared the tag libraries on top of JSP page. That is very common thing. GSTL and Spring tags is different. GSTL is again tag libraries, but for some predefined tag like C, core. Another question here is, Annie wants to declare an exception handler to handle file not found exception in one of her controller classes. How she can do that? A, B, C, D. It's C, exception handler. Apache Tiles. So Apache Tiles itself a framework. I mean, it's a big framework. The reason to include here is just to let you guys know the integration part of it, how Spring integrated, and how we can use internal resource view resolver in multiple ways. We have seen that we can use multiple internal view resolver. But if we want to change the entire framework, let's say you want to change the framework, presentation layer itself with some framework. So you can handle your presentation layer with the help of Apache Tiles, right? You can drive your presentation layer with the help of Apache Tiles, and there are multiple other frameworks. And there is one more frameworks provided by Google as well. You can create your JSP pages with the help of that. So how to integrate these presentation layer directly with your Spring? So that is the reason we have included this Apache Tiles in this class. Apache Tiles is also a templating framework, which is built to simplify the development of web application user interface. With the help of Apache Tiles, it's very easy to develop a UI for your application. Tiles allow authors to define page fragments, which can be assembled into a complete page at runtime. Rather than defining the complete page in one single JSP or one single HTML, we define the pages in fragments so that it can reduce the line of code for your application. It reduce the tight coupling between your code. It becomes loosely coupled. Maintainability will become very, you need not to maintain lots of code. Flexibility, agility, and scalability. These are some points which is very helpful in the case of this Apache Tiles framework being used for your designing of user interface. So these fragments or tiles can be used as simple includes in order to reduce the duplication of common page elements or embedded within other tiles to develop a series of reusable templates. These templates streamline the development of a consistent look and feel across an entire application. So the question is why we need Apache Tiles. So for an example, if you have to develop a web application or website or a portal where you have to design more than 500 static pages or maybe 600 static pages or maybe static and dynamic pages both. So in that case, it is very helpful. So what you can do, you can design the layout of the website often. You can see that the layout of the website often changes according to the business requirement, like changing of logo, changing of content, changing of modules, changing of images. So it's very quite frequent in web application or portal or website, right? In this case, you can use the tiles framework to design the template for the website and use this template to populate the contents. Rather than going each and every pages and changing the content then and there, you can simply use the templating engine or templating framework and you can change at one place and it will be replicated across your application. For an example, you have, let's say, a page, let's say business page, business.jsp, you have account.jsp, and so many dynamic pages apart from static pages like about us.jsp, contact us.jsp, and so on. These are static pages mostly. So what is the common? I mean, how to design so many? Let's say we have a 500 plus pages. Now, what is the thing? So we need to define or we need to design a templates for that. So for example, let's break the pages in different fragments. If you have the maximum fragments, then it will be easier for you to maintain it. So for example, let's say start with header.jsp, and end with footer.jsp. In between, we have a body. You can say maybe body.jsp. In body, you can break it further. You can say left nav.jsp, and right nav.jsp. The more you break, the more it will become easy to handle. Even or main content.jsp, left, right, and main. In the header segment, you can break the header segment in multiple subheaders or maybe subheader.jsp as per your business requirement. I am just telling you as an example, but you can have it less, you can have it more as per your design, how you design your UI. Subheader.jsp, menu.jsp, which will have drop down and all those kind of a thing. This way you can break it. Now these are templates. Now I need to design main pages. I need to design business.jsp. In business.jsp, I need include. I need header. Then let's say I need body, and I also need footer. But in contact us.jsp, I need only few include. I don't need menu. So what I will do, I'll go with header.jsp, or maybe I will minus it, minus the menu. I don't need menu. So maybe what I can do, I can only use subheader.jsp. Then I just need main content.jsp. I don't need left nav and right nav, and then footer. So this way you can dynamically design your content with the help of these frameworks. Though it cannot go into the details of Apache Tiles because the thing which we are going to cover here is the integration part of it. But for your information, I'm just explaining a bit more so that if you want to work on that, maybe in future you can work. So this way you can design your user interface with this templating engine. Something like this. This is the classic way. You can bifurcate in bits and pieces and you can use it. How we are going to use in Spring, that is the main thing, integration. So if you see here in front of your screen, in the Spring configuration file, rather than having internal resource view resolver, Spring provides seamless integration with Apache Tiles. It provides Tiles View Resolver and Tiles Configurer. So if you want to resolve a view, you can use Tiles View Resolvers. If you want to configure your view, you can use Tiles Configurer, where you can provide default XML and index XML. In these XML, you can provide these configurations. So something like this. You have tiles definition XML created here, where you can provide that multiple tile definition with definition name home, where you can include attributes, title, header on all the GSP. Then you can have another definition, let's say home, business, account, and so on. You can create multiple definitions for all the pages. So the pages will be designed in your XML. So include, exclude will be done here in the XML. And then the pages will be rendered on your browser. So then you can create your header JSP like this and so on. So starting with the pom.xml here, the configurations or the dependencies which we need to add. Apart from having core web MVC and all for Spring, we need to add tiles jar as well. Tiles extras, tiles JSP and tiles. There are 3 jars needed for working with Apache Tiles framework. Tiles extras, tiles JSP and tiles Servlet. This you need to add in your POM as a jar file. Now let's go back to the web XML first. In web XML, everything is same as is. Dispatcher Servlet we are going to use and the Servlet XML. In Servlet XML, if you see here, I have tiles view resolver defined and tiles configurer defined. So in tiles configurer, if you see here, I have defined one default XML, which is having the definition for your UI design. So this is your default XML. Here you can define any number of pages for your application. So this is home page, this is a MongoDB page, this is business page. So you can define your pages here. Default JSP, then header.jsp, I have included menu, body, and footer. So here in the default one.jsp, what I have added menu and body only. This way you can design your pages. You can pick and choose. If you want to add menu, if you want to add header, if you want to add footer, if you don't want to add any of the JSP. So this way you can define the templates here and it will render the page like this. MongoDB will be your view name. Business will be your view name. Home will be your view name. This way it will be loaded. So if you open the controller here, the main controller will return home, MongoDB. So this will be resolved from default.xml. So it will pick mongo.jsp. It will load the JSP file from here. So if you see here, there is a no mongodb.jsp, but from the controller, what we are returning MongoDB. Here, this home, that view is getting resolved from here, home, MongoDB and all. So if you see, this is home page where we have header, body and footer. But if we click on MongoDB, it will change the view. There is no header and footer, only body. So it will dynamically change your pages on the basis of your default.xml. That is the configuration file for your application. So this way, the point here for you guys is the integration point for your tiles. How you can easily integrate the tiles framework with your application without changing anything on your Java code or controller. Which of these is not a templating engine? We know that Apache Tiles is a templating engine, right? So it's JSF. Apache Tiles, free markers, Apache Velocity, these all are templating engine, templating frameworks, which is used to give you an handle and replace the complex part from you. JSF is a full-blown framework like Spring. Thank you.